Hello, and welcome to the ALCTS webinar, Introduction to R for Libraries, Part 2. I'm Lisa Lorenzo, a member of the ALCTS Continuing Education Committee. I will be your host for today's webinar. Our presenter today is Clark Iakovakis. Clark is the Scholarly Communications Librarian at the University of Houston Clear Lake. He has worked in both academic and public libraries since 2007 as a page, library assistant, and research and instruction librarian. He has presented at ACRL and ALA on topics pertaining to usability and incorporating data into assessment. He is currently achieving his master's degree in history, and he does not come from a computing or technical background. He brings much expertise to today's topic, and we are fortunate to have him with us today. A few logistics for today's presentation. All attendees are muted to prevent background noise, and we do not have interactive chat capabilities. You may, however, comment on today's presentation using Twitter. The hashtag is ALCTSCE. We do not monitor the Twitter feed, so if you have questions for our presenter, please type them into the question box on your screen. We will have time for Q&A after the presentation. There are also handouts and exercises available to accompany this presentation, which you can download to the webinar tool panel. You should also have received the handout and an accompanying CSV data file in an email from ALCTS yesterday. This webinar is being recorded, and you will receive an email with links to the recording and presentation slides shortly after the presentation concludes. And now, here's Clark. There will be a slight delay as we change presenters.
All right, well, thanks very much for joining us, everyone. We're really excited to have you here today on this Introduction to R for Libraries Session 2, where we're going to be doing some data exploration. Hopefully you got a chance over the last couple of weeks to get more used to the R and RStudio environment and review the handouts. If you had some extra time, hopefully you were able to start that swirl tutorial. If not, or if you didn't catch that, that link was provided in one of your handouts from last session. And swirl is an interactive tutorial in R, and it's a great way of learning R programming. So today, before I start, I want to make a couple of comments. First, this session is not designed for you to follow along. It's really going to be kind of rapid fire, and I'm not going to leave much time or space. So my suggestion to you is to just watch and go back later and refer to the handout and to the recording and go at your own pace. The second thing is I created a data file. This is just a completely random sample of books from the UHCL collection. And this is designed for you to practice some of the concepts that we're going over today. And it's also connected, if you look at the handout that comes with today's presentation, that data file is referenced throughout. So I do want to give you the caveat that you're not going to come to any stunning insights about the UH Clear Lake collection looking at that data sample. It's just pretty much completely random. So with that said, let's move on. That's me. I'm the Scholarly Communications Librarian at UH Clear Lake. And we have a lot to cover today. We're going to go over R packages. We're going to talk about ways of getting your data into R, and then we're going to go into some really fun and exciting data exploration. Just like last time, this is going to be overwhelming. It's going to be kind of a whirlwind tour of R. So if over the last couple of weeks you have been using R and you're getting tons of error messages, then congratulations, you're an R user. And all of us have way more error messages than we do successful commands. So again, just stick with it, refer to the handouts and practice, and really feel free to reach out to me personally if you have any questions. I'd love to help you. All right, so with that said, let's talk about R packages. Now, R is now almost 25 years old, but its user base continues to grow. And, you know, it's kind of funny, we're doing a presentation, a webinar in 2018 on a programming language that was created in 1995. So this speaks on the one hand to the robustness and the flexibility of R, but on the other hand, it also speaks to the fact that since R is open source, users are able to create their own packages of R functions, and those add on to and enhance R functionality. So for example, you could find earth scientists who create libraries of functions to do tasks that they need to do, and then they package that library together and they release it, and then others are able to download it and use those functions. The same is true of statisticians, of psychologists. Data scientists have created packages to help with handling data in R. There's visualization packages, and that's all to the benefit of the R community. This tweet kind of encapsulates something that all of us experience. And he's talking about Python, but the same is true of R, where you'll spend hours trying to figure out how to do something, and then you'll figure out that someone else has already done it. And they've already released it into an R package, an R library. And so that's a very normal experience. And that way, instead of having 25 lines of your own script, you just have one line, and that's the function that someone else has created. To install packages in R and RStudio, you click on, in the bottom right-hand corner in the navigation pane, there's a button that says install, and you can use that to connect to the CRAN repository. This is like the official repository of R packages, and they have certain protocols that others have to follow in order that developers have to follow in order to make their package available. Like all of the functions have to be well documented with help. The functions can't interfere with your RStudio or with your computer. So you can download packages from anywhere on the web, but this is the official, CRAN is the official R repository. And the advantage to installing packages this way is as you type in the package name, it will auto-complete. So you'll be able to make sure you're downloading the right one. In addition to that, you could also just type this command directly into the console, install.packages, and then the package name. So okay, so I'm sorry if some of you are having trouble hearing me. I'm getting some comments that my sound is cutting out. Hopefully this improves as we go along today. I apologize for that. All right, so the install packages function does exactly the same thing as this install button. You're just able to do it directly in your console. The tidyverse is a sort of package of packages. And what this does is it's like data manipulation, exploration, and visualization packages. So in each phase of the data analysis project, there's a series of packages that help with that phase. So when you install the tidyverse, you're getting all of these packages at once. You can install each package one by one, of course, but tidyverse will get them all. One thing to point out is that if you're getting this error message, unable to move temporary installation, this is possibly due to antivirus protection on your campus computer. And I've included some help links in your handout that will tell you how to fix that. And if you can't fix it, then feel free to contact me and let me know. So that would be the first package I would install is tidyverse. But if that's giving you trouble because it is installing dozens of packages, you can just install these few for now. The dplyr package, read Excel, string R, and ggplot2. These are the 4 that we're going to be using over the course of today and next week. All right, after installing a package, you actually have to load it into your R session. When you first open R, the only thing that will be automatically loaded in is what's called the base R, which is just the functions that comes with a standard R installation. So select is a function that belongs to the dplyr package. And if I run select without first loading dplyr, I'm going to get an error. It's going to tell me I could not find that function. So the way that you load a package into your R session is you call library, and then you put the package name in quotation marks. And you have to do that every time you start R. So just get in the habit of when you start your R session, just type in library tidyverse and load it up. All right, so let's talk about reading data into R. I talked about this last time. When you read a data file into R, you're not actually manipulating that data file. What you're doing is creating an object that is stored in the working memory of your computer in a format that R can understand, and you're manipulating that data file. So again, you're manipulating that object, not the data file itself. In order to output an actual file that you can then send to someone, or if you wanted to open up in Microsoft Excel or some other data platform, you have to write that data frame to disk. And I'm going to be talking about this at the very end. All right, so there's multiple means of getting data into R. You can manually create it, which for the most part, you're not going to be doing that. Most of you will actually be importing it from a file that's saved on your local machine. And there's all different packages that allow you to import data according to all sorts of different formats. You can also gather data from the web. So there's a lot of R packages that connect directly to open APIs. For example, there's a Twitter package that allows you to download tweets directly from the Twitter API. You can specify a hashtag or a few keywords, and then you can end up with a data frame in R that has who tweeted it, when they tweeted it, how many retweets it has, and so on. The same is true of altmetric data. So you can pull in, there's a package called R altmetric that allows you to put in DOIs and get all of the altmetrics data associated with each DOI. And there's many, many more. And you can also get data by web scraping. So this is through the HTTR package. And that will go out to a website. It will scrape the HTML from that website, and it will allow you to parse that HTML and extract data from it. So I'm not going to be talking about any of these today. I'm going to be mostly focused on getting data into R using your local file. All right, the first thing you need to do is to set your working directory. The working directory is the folder on your computer that R is going to use to read and write files. It's pretty straightforward. setwd is the function name, and it's just a path directly to that folder on your computer. There's two things to keep in mind with setwd. One is you need to put that file path in quotation marks. If you don't do that, then R is going to look in your local environment for an object called c:/users, etc. So you have to put it in quotation marks. And the second thing is you have to use a /. So for those of you on Mac or Linux, that shouldn't be an issue because by default, directories are separated with a /. But for those of you on Windows, it's the other way around. So here's how you can get around that. You can open up your directory window, you can copy that file path and then paste it into your R session. So here I have a setwd command, I have my quotation marks, and I paste my file in there. And you can see this, you can just do a find replace, and you can say replace the / with a /. And that should set your working directory. In order to get your current working directory, if you ever get lost and you need to know, okay, have I set my directory properly, just use getwd with nothing in parentheses, and that will print your current working directory to the console. So after you set your working directory, you can use // to represent the root directory. In other words, if I'm trying to read in a CSV file, I use the read.csv function. And then here I have /data/books. And that means my books.csv file is in the data subdirectory in my root directory. It's the same thing. / is the same thing as whatever you set your working directory to represent. There's three main functions for reading in tabular data. And when I say tabular, I just mean a grid of rows and columns. Read.table read.csv and read.dlim. Read.csv and read.dlim are the same as read.table. They just have a few arguments set by default, like read.csv automatically sets the separating character to be a comma. Just a real quick overview of text data files. If you've only ever double-clicked on a CSV file and opened it up in Excel, you may not know that underneath that, it's not a nice and neat grid of rows and columns. It's actually just a messy bunch of text. So in text data files, these use what are called delimiters to separate the data values. Comma-separated values use commas. So it actually looks like this underneath the hood. It's got all of these different data values and they're separated by these commas. And then at the end of the line, there is no comma, and that lets the data importer know that it's a new row. Tab separated values rather than commas, they use tabs. And data values themselves are typically in quotation marks. Okay, so last time we talked about the fact that R functions take arguments, and we used sum as an example, and we said sum takes a bunch of numbers that you want to add together, as well as the argument na.rm, which you can specify if you want to remove na values. The same is true of just about every function, and if you run the help function, which is a question mark followed by the function name, you can see all of the different arguments that that function takes. So this one, read.table, which we're about to review, this takes many, many more arguments, and that's a good thing. Because text data files can be so messy, we need to have a lot of control over the way that we bring them into R. So I'm going to go over some of the major R arguments, and I'm going to spend a lot of time on this because it's very important. The first argument is the file, and this is obvious. It's just the path in the file where the data are to be read from, and you use // again to represent your working directory. The next is header. So this is asking, is the first line of text on that your header values or is it data? Obviously, if it's data, you don't want it to be in your header columns, and if it's headers, you don't want it to be read in as data. So you set this to true or false to specify whether your file contains the names of variables on its first line. So again, all of these arguments refer to how is the underlying text data structured. Sep is to specify the characters separating the fields. And I want to make a note here. When I export data from my ILS, it gives me the option of setting a different character as a delimiter. And I always set it to something uncommon, like a caret or a tilde. And the reason for that is titles have a lot of quotation marks and commas in them. And if you're reading those quotation marks and commas in as separating values, that can throw off your data and it can lead to invalid results. So I always separate my files with a caret or a tilde or something unusual. And then when I'm using my read.table command, I set this sep argument to be that character. So my data is read in much more neatly. The next argument to read.table is call classes or column classes. You may remember last time we talked about that different vectors take different types of classes. So there's logical, true, false, there's character, there's integer. If you don't set call classes, then R will automatically try to figure out what the class of those data values are. And that can be problematic for a couple of reasons. In this case, take an ISBN. So ISBNs are numbers, but you're not really going to be doing any kind of mathematical operations on them. They're really numeric identifiers. So if R reads in your ISBN as numeric, what it's going to do is drop that first zero. Some 10-digit ISBNs have a first zero, and that means that the data is not going to be clean or valid. So I use call classes to go in and specify that my ISBNs are always character. That way it will read them in more true to what they actually are. NA strings is asking, in your original data set, how do you represent missing values? So this could be, it could be a space, it could be a hyphen, it could be n/a, it could be no data. So you specify this argument and you say what the data files are. I'm sorry, you say what the NA file, what the NA structure is in your underlying data set. And finally, strings as factors. This I always set to false 100% of the time. By default, strings as factors is set to true, and pretty much any R user is going to keep strings as factors as false. And that's because dealing with factors can be really problematic, and most of us just prefer our factors to be set to character values. Okay, I hope that makes a little bit of sense. The only required argument is file, but specifying more arguments can help bring the data set in faster and in the shape that you want it in. So it's going to ultimately look like this. So I'm creating an R object, I'm and I'm calling that books, and I'm assigning to that the read.table. The file is my root directory and books.csv. Strings as factors is set to false always. Header is set to true. My separating values are comma, and my column classes, I'm saying total checkouts are to be specified as integers. Now, RStudio also has an import dataset tool in the upper right-hand corner in the environment pane, and what this does is run the read.table function automatically. It's kind of like a wizard to run read.table. So it has all of those arguments that we just reviewed. I really don't use this because I like to have more control over the way that I bring my data in, but it's there if you want to practice with it. Just look in the upper right-hand corner. All right, you can read in Excel files as well. But there's a caveat. So there's two different ways of doing it. You can either open the file up in Excel and save that as a CSV file and then load it in with read.csv or read table, or you have to use the read Excel package. So there, in base R, there is no way to automatically read in an Excel file. You have to install the package read Excel. It also comes in the tidyverse, and then load it into your R session using library, and then use the function read_Excel. That's all I'm going to say about reading in Excel files for now, but you can let me know if you have any questions about that. Okay, so we're going to move on now to tidying and transforming data. We're leaving import behind. So after you read your data set in, the very first thing that I do is I call view on it, and that's with a capital V. And this opens up what we're used to seeing, which is like a sort of spreadsheet, a grid, a table of our underlying data. And the reason that I do this first off is it's a good way to just quickly at a glance check some things out. Make sure that my NA values were read in as NA. Make sure that nothing funny is going on with any of my columns. Now you can't edit your data using view. It's only a way to view the underlying data set. In other words, how R read it into your current R session. There's some other functions that you can run on it. So you can call dim to get the dimensions, 4,000 rows and 12 columns. You can call nrow to see the number of rows. You can call ncolumns to see the number of columns. I want to say that if y'all are still experiencing sound problems, then I'm happy to record this session separately after we're through, and I can send you a recording of the entire thing. So again, my apologies to you if you're experiencing audio issues. You can call ster on the underlying, on the data frame, and we talked about ster last time. This is a way of getting a quick glimpse at the underlying data, and this is a good way also of seeing with a class that each of the columns was read in as, because it's very important that each column is read in under the correct class. Okay, so that's some quick functions to explore the data frame. Let's talk about a few important functions to explore individual vectors, or if you want, they're columns. In Excel, we call them columns. In R, we call them vectors. Exploring the vectors. So you use the $ to specify a variable in the data frame. So you can call ster books and then $location, and that's going to print to the console that it's a character vector, that it's 4,000 elements. Every vector in this data frame is going to be 4,000 elements, and then it will print the first few elements. So here, these are location codes. It's CL, which is Clear Lake, and STK, which is in our stacks. Unique returns all of the distinct values in a variable. So you can call unique on books $location, and this is going to show you all of the unique values. In other words, it's just going to remove all of the duplicates. And this can serve a couple of different purposes. One is if you see like a number in there or a subject heading or something weird, then you know, okay, something funny is going on with one of my rows. So that's one thing. It's a good way of checking and make sure the data was imported in correctly. And another function is you can get a quick glimpse as to all of your different location codes. So you can say, okay, I've got my stacks, I've got my juvenile collection, and so on. So yeah, in this case, it's displaying all unique book location codes. Table takes it one step further. So table still returns all of the unique elements, but it also returns frequency counts for that specified variable. So here you can see at a glance, I'm calling table on, again, books $location, and I can see that about 2,300 are from the stacks and 217 are from juvenile. So table is an incredibly useful way of getting quick frequency counts. You can also use table in combination with what are called relational operators, which is like greater than, less than, or equal to. So here what I'm saying is I want a table of books $total checkouts where the total checkouts are over 50. So what it's doing here is it's evaluating each column, each element of the total checkouts vector, and it's saying true or false. Is it more than 50 or is it or not? If it's more than 50, that's returned into the true. If it's not, it's returned into the false. Duplicated is similar in that it also gives you a true false, a logical vector of duplicated values. So I don't have any duplicates in the data set that I gave you, so I created this vector here, Z, 111, 222, 111, 333, 444. So when I call duplicated on Z, it's going to ask, is this element a duplicate? The first one is not, the second one is not, but the third one is. So it returns true for that third one. Conversely, if you put an exclamation mark in front of duplicated, it'll do the same thing. It will say which ones are not duplicated. The first one is not, the second one is not, but the third one is duplicated. I'm sorry, I knew I was going to mess that one up. The third one is not duplicated. Okay, you can also use duplicated nested in table if you want to take those true false values and you want to return a quick glimpse, a quick table of which ones are duplicated. And finally, you can use which to identify which element is duplicated. So I call which on duplicated, and that tells me that the third element is duplicated. Okay, so those are all very important functions for getting to know your vectors. I want to move on now to discuss data manipulation with dplyr. Now, I really gave a lot of thought over, should I teach them how to do data manipulation using the base R commands, or should I just teach them how to do it in dplyr? Pretty much everything that you can do in dplyr, you can also do in base R. But again, going back to what I said at the beginning, base R is over 20 years old, and really a lot of the things that the data manipulation functions are confusing and they're not easy to understand. So what dplyr does is it really simplifies all of that. And so my suggestion is if you really want to become a master of R, then learn the base R commands. But if you're just trying to get stuff done in R, then it's fine to just use dplyr. It's an incredibly powerful tool. It's a package that was created by Hadley Wickham, who's a data scientist, and it really simplifies a number of critical data cleaning and transformation tasks. So this is some of the things that you can do with dplyr, and we're going to be going over all of these: renaming variables, recoding, creating subsets, rearranging, selecting specific variables, and creating new variables. Summarize, we're going to cover in next session. So I've given some help resources for dplyr in your handout. You can also run the function vignette dplyr in your console, and this will bring up a tutorial on how to use dplyr. So before you use it, of course, the first thing you have to do is make sure and load the package. So you call library dplyr. And this is the way that all dplyr functions are structured. It starts with the function name, then it's the data frame, the original data frame that you're going to perform those functions on, and then it's the arguments of what to do with that data frame. And then the output, in other words, what it returns, is a data frame having all of those functions performed on it. So for example, rename is the function. I'm going to rename columns in books, and I'm going to rename the 245AB column to title. That's an example. So let's talk about rename. Names is a function that's just in base R, and this will print to the console all of your column names. So you can see I have call biblio, x245ab, location. A lot of these though aren't really helpful. And if I'm going to be manipulating these variables, I want more helpful and descriptive variable names. So where does that come from, x245.ab? Well, when I initially extracted the data, it was 245ab, but R does not allow variables to start with numbers, so it put that x in front, and a period is the only valid punctuation, so it replaced that pipe with a period. And that happened automatically when I used read.table. R automatically made its variable names what are called syntactically valid. And it did that same thing with the call number. So it says call space number item, that becomes call ... item . So I'm going to use rename to rename those. I'm going to call books, that's my object, and I'm going to assign to books renamed books, and I'm going to for rename, the new name comes first. So I'll rename 245AB to title, and so on. Bcode 1 to subcollection, Bcode 2 to format. A couple of remarks here. One is that I'm replacing my original read in data books with books. You want to be careful about that, because if you mess up, then you have to read the data in again. So it may be a good idea to call when you're originally loading the data into your R session, call it something like original, and then you can perform operations on it, and you'll still have that original data in your R environment. The second thing I want to point out here is I use these commas at the beginning of each line. That's just a matter of style. You don't have to do that. You can include the comma in the line above, and you don't even have to have a line break for each one of these arguments. That's just what I choose to do. And in your first handout, there's a couple of links to R style, and as with any style, it just has to do with following conventions and readability. So yeah, I'm assigning to books all of these renamed variables. The next function I want to talk about is Recode. What this does is it rename replaces the names of columns. Recode is a way of replacing data values within a column. So for example, I'm going to use unique on my books $sign subcollection, and that's going to print all of this out to my console. It's a bunch of letters. It's really completely meaningless to anyone except those who have the code. And the code is derived from our ILS. Those are cataloging conventions. So the A is archival collections, J is juvenile. So what I want to do is I want to recode all of those to be meaningful. So in this case, I'm not calling on the object the data frame. I'm using the vector. So in other words, I'm saying books $sign subcollection, that's the vector, that's the column, is going to have assigned to it a recoded books $sign subcollection. And this one, unfortunately, it's kind of confusing. It's reversed. So the old data value is first and the new data value is second. So you can see I'm replacing all of those letters with something much more meaningful. Then when I call table on that vector, I'm able to see much more meaningful information. So I can see that the general collection has about 2,200 items. There's about 1,000 government documents. So this is useful not only because my data has more meaning, but you can also use Recode in this way. So I could say I want to recode that K through 12 materials variable, and I want to recode that as juvenile. I don't care about the distinction between juvenile and K through 12 materials. So that means that those 35 items are now going to be lumped in with juvenile. And you can do this if you have like one variable that has a whole bunch of different data values and you just only want 2 or 3. You can use Recode to make that aggregation and simplification. Okay, I lied to you when I said that I wasn't going to show you how to do stuff in base R. I do want to talk about subsetting a data frame using brackets, which are part of base R, because it is valuable to know. So, but then we'll talk about how to do it in dplyr. So in the same way we used brackets to subset vectors in our first session, you can also use them to subset data frames. You remember last time we created a vector scale that was a combination of do, re, mi, fa, so, 5 elements. And if I put scale brackets 1, I'll get the first of those elements. Well, it works the same way with data frames, except where vectors only have one direction, data frames have 2. Not only do they have the row, but they also have the column. So for example, if you put books, that's the name of my data frame, bracket 5, 2, that's going to get the 5th row down and the 2nd column, which is the title. So in this case, the title is Fear of Intimacy. You can also use column names for that. So I can say the books subset, get the 5th row down, and then C, you have to use that C to do a combination. So you're creating your own little mini vector in there, combination of title and total checkout. And that's going to print out your title and your total checkouts. Okay, subsetting with brackets is good to know, but the dplyr provides a much easier way with the filter function. All right, so let's say that in my format column, I have books, I have serials, I have videos, I have other types of material, but let's say I only want to get books. Well, first I'm going to use table to see, okay, how many elements are in this variable. Most of them are books and serials, but there's also some microforms. So here's what I'm going to do with filter. I'm going to create a new data frame, books only. I'm going to assign to it a filter of books where the format is equivalent to book. So this is doing that same thing, that vectorized operation over the format column, and it's saying true or false. Does this value equal book? If it's true, it will be added. If it's not, it will be filtered out. I'm not going to talk about this during this session, but there's more about it in your handout, these different operators, and you can also call help capital C comparison to learn more about the greater than, less than, or equal to. You'll notice that there's 2 equals to. That's important to note. And the same with these logical tests. These are mostly Boolean, so y'all should have no trouble grasping that, but there's much more about this in your handout. The important thing for now is that you can use these operators to get more control over what you're subsetting. So for example, if I only wanted books and serials, I could create a variable books and serials where I'm filtering books, and I want the format to be equivalent to book, or I want the format to be equivalent to serial, and that pipe there is representing the or. Obviously, I wouldn't want to use and because it can't be both books and serials. You can also use filter on multiple variables, so I can say book checkouts, where filtering books to get all books and only those values where the total checkout is greater than 0. So you can see how this can be an immensely powerful way of creating custom subsets of your data. And then you can run some analysis. So you can say, how many rows are in my data frame of books with at least one checkout? And what if I divide that with the number of rows in my data frame of just books and multiply it by 100? Well, I'm getting a percentage of the books that have checkouts, which is 64%, which is not bad. You can also use filter to get rid of NA values. So here what I'm doing is I'm filtering books, and I'm using the complete cases function. Remember, complete cases evaluates each element of the vector. In this case, the vector is call number, and it's saying true or false. Is it NA or is it complete, or is there something there? That's why it's so important to specify in your NA strings argument whether or not how your NA missing values are structured in your original data set, because it allows you to execute functions like complete cases. You can do the same thing with duplicate. So here I'm saying filter books, but I want everything that is not duplicated. In other words, exclamation mark duplicated. So what that is doing is it's saying everything where duplicated equals false is going to be returned or is going to be filtered out. So yeah, again, the exclamation mark means not duplicated, false. All right, select will keep or remove only those variables that you mentioned. So this is a good way if you have a bunch of junk columns that you don't need, you can use select to say you specify only the columns that you want. So you can say select from books, only the title and only the total checkout column. Then if I call dim on that new data set, you'll see I'll have 4,000 rows and 2 columns. You can also use select to remove only certain variables. So here I'm saying remove the call ... item ... variable. Arrange is pretty straightforward. This is a way of sorting your data by alphabetical or numerical order. So you can call arrange on books and arrange it alphabetically by title. It will automatically realize that title is a character vector, and so character vectors are arranged alphabetically. But if you use arrange on a numeric vector like total checkouts, then it will obviously sort it from least to most. Or if you use this DSC wrapper, descending, it will sort it from most to least. Finally, mutate. This is a way of creating new variables from existing variables. Next time, we're going to be talking more about the string R package, and this is a very powerful way of dealing with character strings. So for now, the point that I want to make is this. If you look, I'm creating a new data frame, books LC, where I'm mutating books, and I'm creating a new variable that I'm calling LC period class. LC class is created by taking string sub, which is just a way of extracting data from a string. So I'm looking at the call number string, and I'm saying I want to start with the first value, and I want to extract only that first value. So that's going to loop through my entire call number, my existing call number variable, and it's going to just extract that first character. So then I'm able to plot that. Actually, what I'm doing is plotting a table of it. And remember from the beginning, that table will create frequency counts. So I'm looking at the frequency of each LC class, and I'm able to see at a glance that E, H, and P are my highest frequency. This plot does not look very nice. We're going to be making much nicer plots next time, but this is a quick way of getting a sense of your underlying data. Finally, you can put all of this together with this character here, which is called a pipe. And what a pipe enables you to do is to take all of these different functions that I've been describing in dplyr and do them all at once. And if you run this, you'll be amazed at how fast it is. So the pipe is read by saying then. So here's what's happening. I'm saying create a new variable, my books, assign to my books. I'm working with the data set books. Then I'm filtering books to include only book formats and only those items with more than one checkout. Then I'm selecting only the title and the total checkout columns. Then I'm arranging that in descending order by total checkouts. So finally, the last thing that you might want to do is output that data frame that you've created to an actual file. So for this, you can use the write.csv or write.table functions. And these work by specifying first the data frame that you want to write to a CSV. Then the second argument there is the path. So here I'm saying in the root directory, create a new file that's called bookcheckouts.csv. And then the third argument there is I don't want row names. That's set to true by default, and I typically just set it to false. So what this does is writes that data frame to a CSV file that you can then, email to someone, or if you want to look at it in Excel, you can open it in Excel. Okay, and that's it. I know that was again a whirlwind tour through lots of different R functions. Again, many apologies for any audio issues that you may have experienced. The handouts go over everything that I talked about in a lot more depth. And I'm also available for questions outside the session. Next time, we're going to be doing some more analysis and visualization. It's going to be putting a lot of this together. And for now, I think we have a few more minutes for questions, so I'll take those. So please enter those into the box.
Okay, thank you, Clark. This has been really interesting and informative. I know I've learned a lot. So, yep, as you said, we now have time for questions. So if you haven't done so already, please type those into the question box. And then while we wait for some of those to come in, I actually maybe have a question for you. So I was interested in the plots that you mentioned. It seemed like that would be a really useful feature. Do you have any examples of ones that you've created lately?
Oh, I do. I have a lot of good plots, and those are going to be on full display in the next session. We're going to be using the ggplot2 package to create really dynamic scatter plots and line plots and many others. So stay tuned for that.
Okay, great. And then I also was curious, do you tend to use dplyr in your day-to-day work, or do you just tend to use R on its own?
That's a great question. The more that I've worked with dplyr, the less that I've used base R, and just because it just simplifies so much of the data analysis and manipulation process that I really don't see a point in continuing to use base R for most of my day-to-day operations.
Okay. Let's see, I'll wait another minute to see. I haven't seen any questions yet, but I'll wait a little bit to see if some of those come in. Do you maybe have an example of something that you used to do in R but now tend to do more in dplyr?
Pretty much most of those functions that I went over just now. So if my column names are messy, or if I need to recode my variables, that's a really complicated. A lot of that is really complicated to do in base R. So.
Okay. All right, we've had a couple questions come in now. So someone asked, if I understand correctly, this kind of dplyr manipulation can be saved and done to any files pulled from the ILS?
Yeah, pretty much any of underlying data. So if your data is from the ILS, if it's from a vendor, if it's maybe your student population data, anything that you can create a data frame out of and work with in R, you can use dplyr to manipulate.
Okay. How long did it take you to feel comfortable using R?
I would say it took probably about 6 months of use. I did a couple of online classes that were very intense. Our Coursera classes in data science are very intense and immersive. So I'd say about 6 months, and then by a year, I would say I was pretty comfortable.
Okay. Can you explain the usage of the different assignment operators, such as the arrow, equal sign, and reverse equal sign? Oh, I see, equal question mark, I think is that one.
Yeah, great question. So that first assignment operator with the less than sign and the hyphen, that's used to assign values to an object that you're going to manipulate in R, whereas the equals sign, that is how you specify arguments within a function. So there's a function read.table, where you specify header equals true. That's when you use the equal sign, because that's an argument within the read.table function.
All right. Someone else asked, I've had trouble loading Excel files using Reader. Is there any advice for the kind of errors that come up loading Excel files? And it says,
Yeah. Read R, that read R package, which is part of the tidyverse, that's more for reading in text files. There's another package that's called read Excel, and it's just the letter X and the letter L. So you use read XL to read in Excel files.
I think this, all right, so we have one that's a follow-up question to the question about using data from the ILS, asking, but can you save the steps you took on one file and then reapply them to many files?
Oh, that's a great question. Yeah, if you're going to be doing the same kinds of data cleanup operations on multiple different files, you can save that as a script. And you can even actually, we haven't covered it, but you can create your own functions to where it's got all of that underlying stuff in it, but it's only one line. Yeah, that's one of the huge advantages of R, is that you save all of that as a script, and then you or anyone else can run that operation over and over on data that has the same problems.
Okay. And what was the name of the R class that you took?
It was called R programming. That's the first. There's a series of R for data science classes that were created by some scientists from Johns Hopkins University. The first one I took was called R programming, but there's others like getting and cleaning data, and using R for reproducible research, and they're all excellent. And you can do, they're all open through the Coursera platform.
Okay. Just wait a couple more seconds to see if any other last minute questions come in, but okay. I think you had said before that is it all right for people to contact you if they come up with other questions afterwards?
Yeah, please do. You can contact me personally, sure.
Thanks.
Mm-hmm.
Okay, I think, all right, it seems like that's it for questions for now.
Okay.
All right, we're so glad you could be with us today. You'll receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable and help the ALCTS Continuing Education Committee plan future events. The email will also include links to today's slides and recording. You now have the opportunity to receive a certificate of attendance, and that information will also be in the email. So thank you once again to our presenter, Clark Iakovakis, and thanks also to members of the Continuing Education Committee, Mary Reeder and Iping Chen-Gaffey, and to Megan Doherty from the ALCTS office. The support they provide makes it possible for us to present these webinars. ALCTS has other continuing education events coming up. Part 3 of this webinar series will take place on May 30th. See the ALCTS website to register or find more information. And ALCTS also offers web courses, which are 4 to 6 weeks long, as well as 2-day email discussions. Check the website for information on upcoming courses and discussions. Thank you all for joining us today. This concludes our session.